Hi dear students, today let's learn a new lesson of chemistry part, that is chapter number 3, metals and non-metals. So here you see some of the metals and non-metals, right? So usually how do we differentiate them? How are they differ from each other? So how can we classify the substance is metal or non-metal? So mainly based on its physical properties, right? So let's see the physical properties of metals, like their appearance and their size, their color, etc. Okay, so the first one, usually the metals are in a solid state. Okay, all the metals are in a solid state except mercury. Only mercury is in a liquid state. Okay, the metal that is in a liquid state. Then usually metals are very hard except lithium, potassium and sodium. So sodium is a very soft metal and rest other metals are very hard. It's very difficult to break the metals. For example, iron, gold, aluminium, all these are very hard. Then metals have metallic luster. So what do you mean by this? They have shining surface. You have seen gold, silver, copper, aluminum, right? So they shine, right? This is nothing but the lustrous property. And metals are malleable. So malleable is a property of metal. So it is nothing but the metals can be beaten into very thin sheets, like gold chain, silver chain, bangles, all the ornaments that we can make the ornaments from the metals, right? This is mainly it's a malleability. Then ductility. So ductility also, it's the metals can be drawn into wires, copper wire, silver wire. All these are because of its property ductility. Only metals possess malleability and ductility. Okay, then metals have high melting points. High melting points means they need lot of heat to melt. But gallium and cesium, they have very low melting point. They melt in the palm of the hand. Just when we keep it on our palm, that starts to melt. So they have low melting point, but all the other metals have high melting point. And metals have high boiling point also. Okay, they have high boiling point as well as melting point. Then metals are very good conductors of heat. So this already you have learned in your earlier classes, right? Like they are good conductor of heat and also electricity. And among that, the best conductors are silver and copper, and the poor conductors are lead and mercury. So this is mainly because of its reactivity series. I'll explain it later. And also metals are good conductors of electricity. In that also, the silver and coppers are a best conductor of electricity. And the last one, metals are sonorous. That means they produce a sound. Okay, produce a sound when beaten. When you drop iron nail, that makes sound, right? That property is called sonorous. So this is the physical properties of metals. The next one, the physical properties of non-metals. Okay, so all the metals are usually in a solid state, but the non-metals are either in solid state or liquid or gaseous state. So non-metals present in all the states, but metals, most of the metals are solid except mercury. Here non-metals are present in all the three states. Example for solid state: carbon, sulfur, phosphorus, and liquid state bromine, and gaseous state oxygen, hydrogen, nitrogen. Okay, but usually non-metals are most of the non-metals are in a gaseous form. Remember which non-metal is in a liquid form? It is bromine. The next one, non-metals are soft, okay, except diamond, which is the hardest natural substances. So except diamond, all the non-metals are soft. So non-metals do not have lustrous, unlike metals. Okay, they do not shine, except iodine. And non-metals are not malleable and they are not ductile also. They do not possess these properties, malleability and ductility. The non-metals which are solids and liquids have low melting point, and the non-metals which are solids and liquid have low melting point. Except gas, solid and liquids, non-metals are a low melting point, have low melting point and a low boiling point. Next, they are bad conductors of heat, and non-metals are bad conductors of electricity, except graphite. See, graphite, diamond, all these are allotrope of carbon, but it is considered as a non-metal. And last one is non-metals are not sonorous. They do not produce any sounds. Okay, this is about the physical properties of metals or non-metals. So based on these property, we can differentiate the substances into metals and non-metals. Now let us learn about the chemical properties of metals. Okay, so before I explain the chemical properties of metals, let me explain about the reactivity series of metals. So what do you mean by this reactivity series? So it is the arrangement of metals, but how do we arrange the metals? In the decreasing order of their reactivity. Remember, the decreasing order, the metals are arranged in the decreasing order of their activity, and this series is called as the reactivity series, one of the important topic. So reactivity series is nothing but the arrangement of metals in the decreasing order of their activity. Okay, and as you move down, the activity of the metal decreases. Okay, as you move down. And now tell me, which is the most reactive metal? It is potassium, and then sodium. Okay, then the third reactive metal is calcium. Okay, now which is the least reactive metal? Yes, gold. Okay, gold, silver, mercury, all these are what? Very less reactive metals. Remember, based on this reactivity series, different metal shows different property when they react with the other substances. Okay, so their reactivity based on what? Its reactivity series. Okay, now the first chemical property of metal, that is reaction of metal with the oxygen. Okay, so what happens when metals reacts with oxygen? It gives its respective oxides. Okay, see, when copper, reaction with oxygen is nothing but burning. Okay, we are burning the metals. So when you burn copper, it forms cupric oxide. Okay, or copper oxide. All the metals, when it is burn in the presence of oxygen, it gives respective oxides. For example, aluminium. When aluminium reacts with oxygen, combines with oxygen, it gives aluminium oxide. So you should remember its chemical formula. Important it is. Some metal oxides are basic oxides because they react with water to form a bases. Okay. For example, consider sodium. When sodium reacts with oxygen, it gives what? Sodium oxide. Okay. Further, this sodium oxide reacts with water, it gives what? Sodium hydroxide. Okay. Similarly, one more example, when potassium combines with oxygen, it forms potassium oxide, and further this potassium oxide reacts with water, it gives potassium hydroxide. That's what it is given. All these are what? Bases, right? We have learnt in acid, base, salt lesson. Bases are the metal with respect to hydroxide. So sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide. All these are what? Bases. Okay, but some metal oxides show acidic as well as basic properties. Okay, see, some metal oxides show both the properties, acidic property as well as basic properties. So what do we call those metallic oxides? We call them as amphoteric oxides. Remember, amphoteric oxides are nothing but some of the metallic oxide shows both the properties. For example, aluminium oxide and zinc oxide. Remember these two metallic oxides, aluminium oxide and zinc oxides. They are also called as amphoteric oxides. Why? Because now consider this aluminium oxide, this example. Aluminium oxide reacts with what is this? HCl? Yes, it is acid, one of the strong acid, right? So when this aluminium oxide reacts with hydrochloric acid, it gives aluminium chloride. Do you know what is this compound? It is salt. Aluminium chloride is a salt. Along with the salt, it gives water as a byproduct. Remember, when amphoteric oxides reacts with acid, it gives salt and water. Similarly, they also react with the base to give sodium aluminate, that is also salt and water. That is the special property of amphoteric oxides. Not all the metallic oxides possess this property. Only aluminium oxide and zinc oxide possess this property. So they are called as amphoteric oxide. The next one, the reactivity of different metals with oxygen is different. So mainly, as I told you, it is based on its reactivity series. Okay. So metals like potassium and sodium, so they are high reactive metals, right? Sodium and potassium, when they kept open, that is, the oxygen is present in everywhere atmosphere, immediately they catches the fire. Okay, which are the metals they catches the fire? Sodium and potassium. Therefore they must stored in kerosene to prevent burning. Usually kerosene, sodium is stored in kerosene. Okay, you might have seen in your lab. Why it is stored in the kerosene? Because when it is kept open, as soon they react with oxygen and it starts to burn, because they are highly reactive metals. The next is, if magnesium is heated, it burns with the bright flame. Okay, for example, your magnesium ribbon. So magnesium ribbon, when you burn it, it produces a bright light. Okay, because of its reactivity, it is also high reactive metal. Then iron, when iron is heated, it glows brightly, it becomes a red color. And if copper is heated, it does not burn but forms a black coating of a copper oxide. See, reaction with oxygen is nothing but we are burning the metals. Silver and gold does not react with the oxygen even at a high temperature, because they are very less reactive metals. Some metals like magnesium, aluminium, zinc, lead, etc. forms an oxide layer over it. You might have seen aluminium. So if you keep it open, after some days that white patches appear on aluminium. This is mainly because of the oxide, aluminium oxide, means they reacts with oxygen present in the atmosphere and they form a oxides layer. Okay, and which prevents further oxidation. Further they don't undergo the oxidation reaction. They are called self-protecting metals. Which are the self-protecting metals? Like magnesium, aluminium, zinc, lead. All these are self-protecting metals. So the next one, the reaction with the water. So when metals reacts with water, it forms metallic hydroxide. Okay, what are all these compounds? This is base, right? Sodium hydroxide, potassium hydroxide. Then calcium hydroxide is also base. But these are oxides, aluminium oxide and iron oxide, ferric oxide. It is also called as a ferric oxide. Okay, remember, when metals reacts with water, either they form metal oxides or or they form metallic hydroxide. Along with these compounds, they also liberates a hydrogen gas. So here also the reactivity of different metals with the water is different. For example, sodium and potassium, they react very fast. The reaction is very fast with the cold water to form sodium hydroxide and hydrogen, and it catches the fire. Okay, soon when we put sodium in water, that reacts vigorously and it burns, okay, with the pop sound. Then calcium reacts less violently with the water to form calcium hydroxide, but it does not catches the fire. And magnesium reacts only with the hot water to form magnesium hydroxide and hydrogen. Like metals like aluminium, iron, zinc, they react only with the steam. When we pass steam to all these metals, then only it forms respective oxides and hydrogen. But metals like lead, copper, silver, gold, they do not react with the water at all. So this is about the reaction of metal with the water. Okay, some metal forms a respective hydroxide, that is base, but some metal forms respective oxides, aluminium oxide, iron oxide, etc. The next one, reaction of metal with the acids. So this already we studied in acid base salts. Let's recall again. Metals react with dilute acids to form salt and hydrogen. For example, magnesium and HCl gives what? MgCl2. These all are salt. Along with the salt, it produces hydrogen gas. Okay. The reactivity varies from metal to metal. As I told you, for the above metals, the decreasing order of reactivity is, so you have to arrange these elements according to its decreasing order. So which comes first? It's magnesium, then aluminium, and then zinc, and finally iron. Iron is least reactive. Among this, magnesium is a highly reactive, and then aluminium, and then zinc comes, and last iron. Copper, silver and gold do not react with the dilute HCl. Why? They are very less reactive metals. Hydrogen gas is not evolved when metals react with the nitric acid. Remember, because it is strong oxidizing agent and it oxidizes hydrogen gas to produce water, and it itself produces oxide of a nitrogen. For example, copper, when you treat copper with dilute HNO3, it forms copper nitrate and water and nitrogen gas. Here hydrogen gas is not formed. Okay, the next one, reaction of metals with the metal salt solutions. Okay, this also we have learnt already. Let me explain once again. A more reactive metal displaces less reactive metal from its salt solution. For example, now consider iron. Okay, iron nail, Fe, and copper sulfate solution. Copper sulfate is in a blue color. Okay, it is in a blue color. Copper sulfate is blue solution. When you dip iron into this copper sulfate solution, see the initial color, it is blue. After 15 to 20 minutes, the solution changes into green color. So what happened here? So compare the reactivity series, reactivity of this iron and copper. Among this iron and copper, which is strong metal? It is iron. Okay, so iron displaces this copper from copper sulfate solution. It becomes ferrous sulfate, FeSO4. Okay, iron displaces copper from copper sulfate and it becomes ferrous sulfate. So the solution changes into green. So we can infer that in this reaction, the high reactive metal displaces less reactive metal from its salt. Here compare this magnesium and copper sulfate. Magnesium is stronger than copper, so magnesium displaces copper from copper sulfate and becomes magnesium sulfate. Similarly, zinc and copper. Here zinc displaces copper from the copper sulfate, it becomes zinc sulfate. So this is about the chemical properties of metals. So in today's class we have learnt about the physical properties of metals and non-metals and the chemical properties of metals. Under that we have learnt about the reaction with the oxygen, reaction with water, reaction with acid and reaction with the salt solution. Now it's time to give you a homework. Okay. So homework first one, an example of metal which is at liquid at room temperature and which one can be easily cut with a knife and which one is the best conductor of heat, which one is a poor conductor of heat. Okay, answer for these questions. The next question, explain the meaning of malleable and ductile, these properties. And the third one, give reason. Why is sodium, potassium, lithium are stored under kerosene oil? The next, platinum, gold and silver, they are used to make jewelry. The next one, water amphoteric oxides, give two examples of amphoteric oxides. The last one, an element react with oxygen to give you a compound with a high melting point, and this compound also soluble in water. So you have to identify which element is this. Okay, thank you, and please find the answers for these questions and write it in your notes and upload it to CISO app. Thank you.